Cole Cerrato is an assistant professor in the College of Agricultural Sciences at Oregon State University. His research focuses on the chemistry of foods and beverages with a focus on smoke-affected wine analysis. Cole, thank you so much for taking the time today.
No, thank you for having me.
So to start, could you tell the audience a little bit about your research related to how smoke is impacting the wine industry?
Mhm. Yeah, so my research specifically is looking at several things, specifically coming from the chemical perspective. We've known for a long time about what the chemistry is that is associated with some of the markers about the smoke and how it's getting into the grapes and eventually into the wine. But one of the things we've been asking for several years, or at least since the beginning that we've known about this problem, was that the chemical markers that we had known about weren't necessarily adding up in terms of flavor. They were great markers, they still are great markers, but we knew that the flavor wasn't adding up. And so some of the more recent research that we've done is mostly looking at what are some of these other chemicals that might be in smaller concentrations that are more difficult to detect. What are some of these other flavor compounds that are making up some of these flavors that are creating this kind of like ashy and smoky flavor in a smoke impacted wine?
So when you say chemical markers, can you define what that means?
Mhm. Yeah, so the chemical markers, there's two ways to kind of talk about it. The first one is the marker that we use to detect how smoky something is kind of the first way. The second way is kind of coming from the source of where did this come from? And so when there are wildfire events or just any type of fire, if you are sitting around a campfire and you smell that campfire, these are the chemical markers that you're smelling. So we would say these chemicals are made up of things like guaiacol, cresols, and syringols, and plants have different amounts of each of these. And it's these markers that are actually getting into the skin of the grape and eventually into the wine themselves. So basically, we can follow the chemicals as they come from the source of the material that is being burned as they get into the skin and eventually into the wine. We can track all of that throughout. And so these are the markers that we're looking at. The class of compounds that we would call phenols would be those guaiacols, cresols, and syringols.
So in that tracking process, how do you mentioned the difference between a or the potential of like a campfire versus like a wildfire. How do you track that, and what kind of how sensitive are the grapes like in terms of proximity or and maybe is it density or what does that look like?
Yeah, so that's a really good question because underneath it is a lot of variables. And so this is a common concern for a lot of winemakers is we'll often field phone calls, things like that, from them asking if a wildfire that may be in Canada is impacting the vineyards here in Oregon. And so there is a certain sense of, say, distance that can play a role in how impacted or not the wine is. And so when we're seeing, say, for example, last year we were getting some smoke from Canada, here in Oregon, it was okay. Like as the smoke kind of burns, or excuse me, as the fuel burns and the smoke goes into the air, fortunately the sun can naturally kind of degrade some of these chemicals. So these long distance smoke events that are occurring often don't impact the wine and the grapes nearly as much unless there is a ton of smoke. So this is a second variable, would be the density of the smoke. So if we look at something like 2020 here in Oregon, the wildfires were both close and it was dense. And so in that case, the sun wasn't able to penetrate deep enough into that smoke layer that we had. And so here in Oregon, California, Washington, the wine industry was deeply, deeply impacted because there was just too much of it to deal with. So distance and density makes a huge impact. For some of the um, sometimes I believe that there is sometimes even just a humidity impact. We can see two different vineyards that are next door to one another. One can be smoke impacted, one not. Same hill that they're growing on, same varietal that they're often growing. Why was one impacted more than the other? So there is some belief that there are like local microclimates, whether it's humidity, temperature, et cetera, could also play an impact. One of the things that we also know about is that different varietals, different strains of wine grapes are more susceptible to kind of attaining some of those ashy flavors, some of the smoky flavors than other varietals. So, for example, um, one of the probably the most affected is oftentimes Pinot Noir. It's grown here in Oregon at very large volumes. We have very good Pinot Noir here, and it is very susceptible. But if you look at something like the Syrah that you often get out of California, they tend to be a little bit more resilient in terms of attaining some of those ashy flavors. We're not entirely sure at the moment what that is. I know there is some research going on right now. We used to think there was the thickness of the skin played a role, but I think that's starting to get turned on its head a little bit as we kind of evaluate how the chemicals are getting into the skin and coming back out of the skin during the fermentation process. So there's some really interesting research that's in the works right now where they're looking at how certain chemicals found in the skin of the grapes themselves are able to hold on, retain, or even block some of the smoke from getting in. So it's a lot of
So
variables to answer the question.
yeah, so the you mentioned both the flavor being impacted, the amount of sunlight that the that these places are able to get. How and then you also mentioned there's a potential of both going in and coming out these chemicals. Is there a sense for the capacity of what grapes can handle in terms of the chemicals? You mentioned three different types of I think you said YSL. I
Yeah, guaiacol, cresol, and syringol. The,
yeah,
the overall class is just called phenols, is what we would say
phenols.
too.
Okay. So is there a just thinking about like flavor or the ability of the grapes to survive, is there a sense for um how resilient the grapes or the vineyards are with regard to the this density or the proximity of these different fires?
Yeah, so what we know about these chemicals is they're actually natural to all plants. So all plants have these three types of chemicals to some varying degree. So if you say I'm looking outside right now and there's this big oak tree in front of me and I'm seeing the tree and it's standing up on its bark, supporting it, and that bark is made up of a class of chemicals called lignin. And it's a big branching chain of molecules made up of phenols. These phenols, this chain of phenols include guaiacol, syringol, and cresol, that same class of phenols. And in all the plants here on Earth, there's some varying degree of those three types of chemicals, including wine grapes. And so the health of the grape isn't necessarily impacted by the presence of these phenols, the presence of these the glycols, et cetera. In fact, there are ways that even as these phenols are being accumulated in the skin of the grape has a clever way of mitigating this influx of these phenols. And so, what early Australian researchers found was that these phenols were attaching themselves to something that grapes, as they ripen, have a ton of, and that's sugar. And so they'll attach a sugar to these things and it makes it a little bit more soluble. And so while it doesn't impact the health of the grape at all, there's very, very tolerant. Even we as people, if we were to drink some of these like high smoke wines, the glycol and these phenols, we have a very high tolerance to them because they are so natural to a lot of the natural products in there. But what makes this tricky is that when we start looking at some of the defense mechanisms it has, as it is having an influx, it's attaching these sugars to it, is that the phenols will detach from the sugars during the aging process. And so over time, like with wine, we'll often age it 6 months to a few years, depending on what kind of wine you're making. Is with the sugar bound to it, you can't necessarily taste that. That's not a flavor quite yet. It's a little too soluble in your mouth. It's not quite as volatile as a lot of these, like the esters that belong to some of these fruity flavors or these thiols that belong to some of these like tropical flavors. They're not as soluble as those. But over time, during the aging process, the sugar will break off And what can sometimes happen is a wine that isn't necessarily smoky in the beginning becomes smokier because that sugar is getting broken off and it's creating that molecule back to its original state again. So the short answer to your question is it doesn't necessarily impact the health of the grape, but it can impact the overall flavor in a longer term, depending on how it's interacting with these things. What probably impacts the health of the grapes the most um, could be things like temperature, if there is a very, very close wildfire, or if it is far enough away, but it's blocking a lot of sunlight, it can reduce the growth as well. But oftentimes the winemakers and the vintners have the ability to leave things on the vine a little bit longer. So overall, the health of the grape and even the health of the consumer is probably going to be okay with these specific chemicals. It's more so for humans, it's the particulates in the air. For the grapes, it's more so about getting exposure to the sunlight and uh, exposure to sunlight and temperatures that are good for growing.
Yeah. So the kind of impact to the wine industry is that the change in flavor profile is perhaps less appealing as it gets smokier and smokier, and then they're not able to sell the wine. And that just creates a vicious cycle downwards. And so how can vineyards prepare for wildfire and smoke related impacts?
Yeah, so this is a challenge for a lot of winemakers. So currently, the winemakers do have several tools at their disposal. Um, Oftentimes, if there is kind of a light smoke event, one thing that winemakers we always tell them to do is just have your grapes tested before there's ever a wildfire event. So, like I was saying before, these chemicals that are in all plants, they're in the wine naturally, but oftentimes there is a threshold that you can taste something. And these smoky flavors, it's not kind of like the same smoky flavor you would get from like barrel aging or something like that. It has its own different flavor that is associated with some of the newer research that we're doing. But um, with some of these, the winemaker can use some of the tools at their disposal to reduce the amounts of the compounds that are in there. For example, they can use things like activated charcoal. They can use things like bentonite, which is kind of a clay that they can put in there to kind of remove things that are unwanted. They can do something as simple as blending. And so they have a lot of tools that they can do, but what makes it challenging is that if they don't have the availability of, say, for blending an unsmoked wine, or sometimes the other techniques such as activated charcoal or even reverse osmosis. The challenge with that is it strips out all the good chemicals as well as the bad chemicals. And so the mitigation sometimes requires a lot more ingenuity or a lot more collaboration with other winemakers where they can perhaps purchase a wine to blend with or go to another state to look at some of their utilities as well. I've seen some of the winemakers here doing skinless fermentations. So they will do a red wine that is a white wine. So I've had a few white Pinot Noirs from 2020 that were actually really good. They're very tasty. And so because of that lack of skin contact, where a lot of those volatiles kind of reside during the smoke process and even during the fermentation process, if you remove the skin aspect of it, you can still get a wine that has a lot of the flavorful characteristics that we want, but it doesn't necessarily have the same color because you're not fermenting it on skin. And so there's a lot of tools that the winemakers can use that they can potentially use to mitigate this to some extent, but it's not a perfect system. I think what we're trying to do more lately in the research realm is to find ways that are a lot more specific. And so where I had done my graduate work, it was a lot of like disease focus. And so that's kind of like the analogy that I use for this is like with a disease, you want to target the disease. You don't want to target the person or the host or anything like that. Because if you're treating a cancer and you want to treat the cancer, you don't want all these different side effects that can happen. So in the analogy here, if we have something that is able to treat the chemicals specifically associated with the The phenols, or even this new class of compounds that we discovered back in 2023, these thiols, if we can target these two classes of compounds, then maybe we can mitigate the smoke flavor and the ashy flavors without impacting the overall flavor of the wines that winemakers and the consumers want to produce and consume respectively. And so this is still very new, and we're still kind of like taking a stab at it here and there. And we're working with collaborators that are uh, food scientists, chemists, engineers, and things like that in order to give winemakers more tools in order to prevent some of these chemicals from getting into the grapes themselves, or by pulling them out of the resulting wine.
Yeah. So you mentioned testing earlier. Is the testing um, such that you can have you'll have a pretty precise understanding of what whether the flavor profile or the chemistry looks like, so that the toolbox that you're creating um, is directly or as you said, specifically usable to address the whatever it is, the percentage of or whatever the flavor profile or chemical profile is of the grape.
Mhm. Yeah, so the testing that we do specifically looks for those markers, whether it is the those volatile markers, those phenols I was talking about, or even the those sugar-bound molecules as well. So we can test for both of those, and we're even developing methods for some of those thiol compounds that I briefly mentioned as well. And so what I was kind of alluding to earlier was some things that will tell the winemakers is to get their testing done even in a year when they don't have any smoke. And so in the science world, we would just say this is our control. This is
Hmm.
what we know is what it looks like without a smoke event. And so the technology nowadays is very sophisticated, and the lab that I run is able to measure some of these compounds much more efficiently than we had done, say, 20 years ago. It's interesting, some of the history with some of the measurements, the analysis that we have is this problem was first noticed in Australia back in the early 2000s. I think it was around 2003, because they were having a lot of bushfires. And Australia is known for a very large wine producing country. And basically, their research, when they were looking for some of these chemical markers, they were basically comparing the chemical markers from things like beef jerky and smoked meats to these smoked wines, and found, oh, look, these things match. And so, like I was saying earlier as well, there was another class of compounds that they had known was floating around out there, but the technology wasn't, 20 years ago, wasn't quite what it needed to be in order to measure some of these compounds. But nowadays, we have a whole bevy of instruments that we can rely on in order to measure these things highly accurately and down to a very low concentration nowadays as well. So we can get very accurate and precise information out of just a number of compounds that we couldn't do at the outset of all this research back when the Australians were doing this 20 years ago.
Yeah. So I'm curious, what does resilience or what does resilience and sustainability look like in this context? Is it more smoke tolerant vineyards, or is it being able to react with kind of the toolbox that you've described when when there has been a um fire event?
Yeah, I think this is one of those answers where we have to diversify our approach to it. Kind of putting all our eggs in one basket for this may not be may not be the most beneficial choice for a lot of the winemakers. I know we kind of gravitate towards our favorite wines, but there's also the sense of having to adjust with the reality that we're facing as well. And so as we see that temperatures are changing across the West Coast, there could be an eventuality where we're starting to see some of these like southern grapes, warm climate grapes, slowly migrating north. Uh, but in terms of like the smoke and how it impacts the grapes, and in terms of their resilience, that's still something we're trying to figure out. I don't have like hard answers for it. We have very anecdotal to loosely good evidence about the natural resilience of certain varietals. but it's still, there are so many variables like we discussed earlier that even a Syrah can be impacted by smoke to a certain extent, at very high concentrations of smoke density. And so I'm not aware at the moment of, maybe there's room for some type of breeding program that could have maybe the skin of a Syrah, if that truly is what is preventing the smoke from getting into some of these. But at the moment, sustainability is going to have to take a very varied approach, whether it is that kind of breeding that someone might do. It could be some of the mitigation. There are some mitigation techniques that people are looking at here at my own university, where they're looking to put like spray coatings on the grapes, and these spray coatings would give the opportunity for, one, the grapes would still be able to grow, and it would potentially, if they get they're trying many different formulations of this spray coating, but it would give the opportunity for the winemakers to put this coating on the grapes and potentially prevent some of the smoke from getting uh, into the grapes, whether that is, blocking it, absorbing it, or adsorbing it. They're still looking at a lot of different formulations for that.
That's super interesting. And I'm curious, when doing kind of that type of research, what is the like what is the mechanism for testing on you mentioned all these varieties. Is it that you're just testing one at a time, or are you able to look at like an entire regional portfolio of grapes? And is this maybe something, an application of AI or some other type of technology to help with the research?
Yeah, now that you mentioned that, there is a collaboration that we are developing with um, with AI, but I don't know if we're quite at the extent of using it for smoke quite yet. It's a new professor who's working here, Dr. Luya Ma, who is developing food systems with AI, and she's doing some fantastic work, but I don't think we're quite at the level yet to where we can use it to do any smoke predictions that kind of circumnavigates the whole analysis portion of it. There are no like visual markers, no visual indicators that tell us whether something has smoke or not. This is down at the chemical level. You can't even take a grape and pop it in your mouth. What's fascinating is like the human is often more sensitive than a lot of the instruments that we have. We always have been. We just don't know how to name a lot of the chemicals because it's a very complicated, complex matrix that we're consuming. But what's unfortunate about this is that even if you were able to pop a grape in your mouth and eat it, you would still not be able to figure out if it's smoke impacted or not. It has to go through certain processes, whether that is the fermentation process, which is kind of what's triggering this kind of extraction out of the skin, and then it has to go through our own analysis. And even then, we talked a little bit about those bound compounds, those sugar bound compounds. So those aren't soluble as well. We can't taste those, and so we would end up needing to analyze those. I feel like I strayed from your question a little bit. So if you wouldn't mind repeating it, I can maybe address one other point that you had in there as well.
I think you addressed it. I was just thinking about how you might do large scale research, maybe through AI or machine learning or
Hmm.
something like that, or maybe it's some sort of some other kind of computational methods. But um, as you were talking, you mentioned fermentation, and I'm curious if there's anything upstream of when the grape is a grape that you're doing that's I don't know the process of how grapes grow, but is there anything like if fires happen earlier on in the process versus in very late stages of the process of grape where you're able to see different things, or what does that look like?
Yeah, so this was actually addressed, I think, kind of recently. Australia is still very much in this game of doing a lot of the smoke research, and you know, what they had found in a recent study was basically if there's a berry, if there's smoke, there can be impacts.
Hmm.
And so we know that, the early testing, so there is a point in a grape's life called veraison. And so this point is when the grape is kind of switching its maturation cycle. And so this is like a hormonal thing. You'll see the colors change. All red grapes start as green pre-veraison. So over time, as this kind of shift kicks in, you'll see that the grapes get a little bit darker, the flavors change, the sugar content goes up, the acidity goes down. And so this was one of the questions they had was, is there an issue pre-veraison versus post-veraison? And the ultimate, what they had found out was, nope, it's a little bit harder to test early on. And we've seen this with grapes. Grapes are the more challenging matrix to kind of work with. But if we allow those early age pre-veraison smoked grapes to age a little bit and then test the grapes, test the eventual wine, they're still able to see that the smoke is getting into the skin structure is still attaching some of these molecules, and then they eventually get into the resulting wine. So fortunately, if there is no berry, so if there are smoke events that occur between seasons, I think, for example, with the Canadian wildfires that are occurring towards the East Coast right now, assuming they don't have berry set quite yet, and some of the vines that grow on that coast, then they're probably going to be fine. Like we don't see a lot of fires that are happening before the berries are produced that are impacting the quality of the wine and the pre berry.
Yeah. In a similar vein, I'm curious if the impact is this of the smoke is the same if it's um like a dry day. I think you mentioned humidity earlier. If it's a dry day or if there's
Potentially.
rain that happens right as the smoke is over the affected area, does rain impact the absorption or anything like that when there's kind of a smoke and then another weather event?
Yeah, not entirely sure. Like we're piecing these puzzle pieces together. Um, we are working with someone who does these large model um, weather mapping systems as well as multiple statisticians to put all of this information together because this is not a single variable thing. Like I love like doing experiments that are just like you change one thing and then test it, change another thing and test it. But that's not the case when the temperature is different one day to the next, the humidity is different one day to the next, the smoke is different one year to the next, sometimes one day to the next. And so it really does require a higher level of sophistication when it comes to uh, large data modeling, when it comes to the statistics that is required to kind of tease apart all of these different variables. So, like, the short answer is we're not sure, but the hopeful answer is like we're hoping to figure out a little bit more in the future as we're able to put some of these puzzle pieces together. And so, this is a large multi university grant that has been put together by Dr. Elizabeth Tomasino here at Oregon State University, who is working with this highly collaborative multi-collegiate team to figure this out at a larger scale.
So that leads me to my last question, which is what does the future of this research and this work look like? Maybe on a I don't know 3 to 10 year time horizon. Are there any breakthroughs on the that you see in the near future or within the next few years?
Mm-hmm. Yeah, so kind of speaking about kind of like going around the horn with a lot of the work that I know about here at the academic level. Like myself, I'm looking to see what else is in these things. We had discovered that there were these new class of compounds that were involved in the flavor of that ashy flavor of wine. It's that flavor that really lingers called thiols. And we know there's more out there to kind of pick apart as well. There are more chemicals that are in this that could be impacting the overall flavor. And again, if we use that analogy for kind of like the disease treatment, we want to be able to treat for these specific chemicals that are involved in these different flavors that are unwanted. And so the second step would be talking to some colleagues, whether it's over in the Department of Chemistry or Engineering or Physics or anything like that, and looking at how we're able to selectively remove some of these compounds without impacting the overall quality of the wine. Some methods have been tried with this with limiting success and limiting sustainability, but there is definitely kind of resources to build on when it comes to the work that I'm doing, the work that they're doing, as we kind of like inch our way towards this kind of like specific sustainability for the overall industry. They're definitely moving more towards that kind of that film study is highly a lot of people are asking about that kind of study because they want to be able to just apply something once to grapes and just leave it alone and not have to worry about it. So there's a lot of interest in doing something like that where it would be akin to applying something like a pesticide or something like that. You just go out
Mm.
in the field, you spray your stuff, and you're good to go. Same thing, you'd spray these grapes with these films, these coatings, do it once a season and you're good to go and you're protected from the smoke, assuming that we have the correct formulation. And so that's one of the things they're looking at right now is ensuring that we have a real high quality formulation that one blocks the smoke from going into the resulting wine, and two, it doesn't impact the overall health of the grape. And so they're doing some really cool work with that. I think there's still a lot of room to grow when it comes to, like we were just talking about, the modeling. We don't know what variables matter most when it comes to smoke. We know that proximity is a big one, and we know that density is a big one. But what do we say to these winemakers who, are next door neighbors and don't understand why they have smoke impact and why their next door neighbor doesn't?
Mm.
And so we're still trying to understand kind of the nuances of these many, many, many different variables that are out there in order to give winemakers kind of better tools. It goes back to that old like 1980s after school special, knowledge is power kind of thing. And so that's what we're trying to give them. We're trying to give them that knowledge in order to make the decisions that they need to make when they need to make them, because oftentimes these wildfires happen right around harvest. And so it makes it
Mm.
very difficult for these grape growers to anticipate whether or not they're going to be able to sell their grapes or make the wine. And so the other thing I think we're hoping to do, especially with like a podcast like this, and why I'm so appreciative of and very willing to do some of these talks like this, is education. So again, it goes back to that knowledge is power. Like the more we can kind of teach winemakers what's out there, the more that we can show them and tell them to, hey, get your grapes tested early. Even on non-smoke years, get your grapes tested when you're ready to start picking grapes or a few weeks beforehand. If they want to get their wine tested, we can teach them how to taste the wines. We can teach them how to do rapid fermentations at an even smaller scale that allows them to make these resulting wines very, very quickly. And so education is a part of that. And that's kind of where I'm at the forefront of as well, is not just the research, but also the education aspect to teach both the winemaker, the grape grower, and the consumer kind of what's going on. Why are grape growers, why are winemakers so hesitant to get some of these out there? You can sometimes find a smoky wine on the shelves, but most winemakers aren't necessarily willing to put that out there because that's not it's not necessarily what they want to have. That's not the flavor profile they were looking for. Um, some people are okay with it, is what we're finding in some of the research, but sometimes you say you get like a year like 2020 and some of it it's very ashy, kind of like
Mm.
tasting it's kind of like licking an ashtray sometimes, and that's that flavor
Yeah.
profile that people are not a fan of.
Yeah.
So there's a lot on the horizon, and there's a lot of like very cool stuff to kind of come out of this. But I think in the meantime, there's just a lot of conversation and a lot of just doing the work day to day.
Awesome. Well, Cole, thank you so much for taking the time to share your research and your insights, and I hope we can continue the conversation down the road.
No, absolutely, anytime. Thank you for having me.